So now we have 10 minutes to take questions. So if everybody wants to ask questions, just raise your hand.
Jean-Paul Tequer. Larry, you mentioned about technologies that is potentially can replace the bolts and holes in point-fixing glazing. Can you tell us a little bit about it?
There's some high-strength heat-cured adhesives that are used in that application, and they're used in various industries around the world. And when they are, adequately designed and engineered and autoclaved, because our industry has autoclaves, there's some very, very high-strength materials that can be used and engineered to replace drilled glass. And the advantage of that is really being able to attach insulating glass. Because today, with drilled glass, especially through insulating, you have the risk of running condensation within the units due to just breaches of the insulating glass. So it works very well. It's just in its infancy and coming along.
Yes, Mark Garland from Toronto. A couple of questions for Larry also. Does structural silicone, so the aluminum extrusions these days are mostly Duranar coated or some kind of high quality paint. Do you apply the silicone directly to the paint?
The common practice today is indeed applying the silicone directly to the high quality fluoropolymer paints. But there's a process to get through with that, because somebody who comes up with a new paint, that's not proven technology, you've got to have a reasonable method and an alliance with a paint manufacturer so that he at least knows what's going on. Many of them don't, but there's been great success in the industry with fluoropolymer paints.
Mm-hmm. And then secondly, that trapezoidal joint, is that in practice anywhere?
That is not currently in practice.
And do you see curtain wall manufacturers adopting that?
I see that they will adopt that mainly because of the ability to provide that design freedom, and just when you do the basic math on the reduction of the aluminum expense and the whole green movement, I think that's going to come. So it makes a lot of sense.
For Mr. Yuanda, I'm sorry I forgot your name. Are some of the panels curved? Are they curved, unitized curtain wall?
I would like to explain to you. All panels is plate one. It looks this is curved. In diameter, minimum diameter is 10 meters in the corner. So even this part also using all segmented panels.
So they're all flat.
So one circle is 141 panels, and the glass is 10 kind of glass. And this is, but every panel is different because this is all L-shaped.
Right.
Okay. And this glass is also using this is low iron glass. Okay.
Yeah.
And reflective. This is low E coating in the laminated layer. The 12 plus 12, and combined with the SGP film. Okay, thank you.
And then that hot water system for the condensate control, is that 90 degrees centigrade or Fahrenheit?
Yes, I think more difficult. This after tested, this is okay. This is all gasket together.
No, but how hot is the water? I'm curious.
This is 6 cubic, but this is 5-star. So the accumulated in the bottom region is more bigger than the cold. Water temperature. Water temperature is 90 degree. Highest one is 90 degree inside.
Celsius?
Celsius, yes.
Celsius, really
yes.
hot. Yeah.
Yeah, okay.
I have a question about the ArcelorMittal presentation. These composite columns. What are the concrete requirements for this?
So normally, if you follow the codes, you cannot use a grade of concrete higher than 60 for composite design. But most people are using sometimes even 100 MPA concrete just because the stiffness is changing. So if you limit the design, the yield of the concrete to 60 and use 100, you can have a stiffer building. This is what most people are doing today for skyscrapers.
Yes, a question for Jean-Claude.
Yes.
So the Shanghai Tower, those columns are not encased in concrete?
The Shanghai towers, they are encased into concrete.
Oh, are they? The
yes,
ones...
but they are plates,
yeah,
all welded together, so they are all tied together. So there is no zone without steel. So if they are like building a vessel encased into concrete.
And not to be thick, but the discussion that you were presenting about the composite column, you're substituting reinforced concrete for those steel sections in that column in order to comply with the ACI 318. Is that what you were doing there?
No, we are replacing the build-up sections by insulated H-roll sections, which means it will be much faster to erect because you have one column is very light, so you have less splices to be done. You do one splice every 3 floors instead of doing one splice.
No, I understand that,
yeah.
but to comply with the building code,
so you comply with the LRFD because LRFD allows you to use untied beams or build-up sections into a composite sections. Mm-hmm. But in China today, there is a requirement that you must link all the shapes all together. So, and it has been based on one test in one laboratory that has been done specially for the Shanghai center. And my belief is that they neglected, when I explained the shear forces, they neglected that the weak point was the concrete and not the steel. Mm-hmm. So they use the wrong calculation, and when I explain how to do this calculation, if you say the weak point is the concrete because you have something strong, something weak, and something strong, if you take that into account, then you can use this method to design skyscrapers. Mm-hmm. And now it's just a question, we need to find a project with an engineer who wants to use that as an option, and we want to find an investor, or we are looking for an investor to test it here in China to prove that this method is correct. So if you are designing a big tall building, ArcelorMittal will pay for all the tests in China to prove that this method is valid. But it's valid in the United States today.
Thank you.
A question for Yuanda. How do you approach the fire propagation problems in the Shanghai Center Tower with the two walls?
I think fireproofing design is very important. So in the first stage, every beam in 56 diameter is divided to the 25 different parts and connected with the, but now only left, this is bottom beam is divided to the 25 section. Other is all combined together. So this is related to the, this is fire quantity. When firing, no so many fire exist in here. So this is only using outside fireproofing paint. This is two floor, 3 floor. 3 floor is painted, other is no. Okay, thank you.
Jean-Claude, your comments about the splicing of the shapes across the street here, that they don't preheat and they don't remove the slag, that's very troubling. Have you discussed that with anyone in the project, involved in the project?
Yes, I explain it, and I'm explaining to a lot of people, not because I want to promote my beams, but I'm really worried about what will happen after an earthquake. They simply don't do it because they are not used, and this is the first time they are using so thick material They just extend what they were doing on the small material. If you have 10 millimeter plates, you don't need to do all these things. But when you are talking about 100 mm plate, you have to do a lot of things on it, and they simply don't do it. And for example, on National Geographic channel, there was a movie, I don't know if you saw it, on the bird's nest. They were welding it, everything, when it was between 10 and 20 degrees outside. They were welding it during the night to avoid the extension of the joint. And to me, the bird's nest will fall when there will be an earthquake, because it's not done properly. There are a lot of cracks in the welds. And it's an education process. All the engineers, normally they stay in front of their computer, they optimize the building using high-tech softwares today. They don't go on the job site. You talk to project managers, they don't go on the job site, or they say, we stop the design to the main design, we are not doing the detailing design. It's done locally, so we are not responsible. But unfortunately, you need Northridge here in this part of the world to have to change the mentality of the people. They don't know. They simply don't know. And the inspectors, if there is an inspector, even doesn't know how to check. It's very strange, but it takes time. And
Okay, at the end of this session, I would like everyone to give you a big hand to thank all the speakers for their excellent speech.